It is nice to have all this information gathered in one place for us, showing how data in NTFS is allocated to a file, plus these attributes right here. And I'd like to show you that if you right-click and say Position and go to File Record, we'll jump to a different location on disk. Now it's different sector number, so we're no longer looking at the content of this file. Rather, information about a file on NTFS is coming from MFT master file table, which is a long list of what we call MFT entries, or WinHex refers to them as MFT records. It's the same thing, right? So we have location of MFT, and it's made up of MFT entries, and it's a long list. It's like a database. So that's the content of MFT, and each file over here has the content that looks like this, and it's this information stored inside master file table. So this here in my diagram is MFT, and this is an example of MFT record for this file that we were just looking at. Each MFT record is a list of MFT attributes. There's a 42 byte size header at the beginning, and with different colors, this display showing us a sequence of attributes present in this specific MFT record for our file cobra02.jpg. Let's take a look at typical MFT attributes. Every MFT entry or MFT record, file or directory has a standard information attribute and at least one file name attribute. So the attributes can be large in size, but most of the attributes, except the actual file data, fit inside the MFT record. But the data attribute, which has a list of, in our case, like 28 clusters in this file, is called a non-resident unnamed attribute type. I'll show you here. And this is this internal structure. And at byte offset 40, right here, this is hexadecimal 40, which is decimal 64. It contains what we call the data runs. So our file has one single data run made up of the number of the first cluster number and the count how many clusters are present in this data run. So the data attribute itself, which will have this type of structure internally, right here, our data attribute. So it contains the actual data run and the run list information. So it can be actually resident if the file is very, very small. It can be resident and named or resident and unnamed. It can also be non-resident. In our case, our file is non-resident because it's allocating as many as 28 clusters, and it also can be non-resident and unnamed. And this is the most common, just like 90% of files that that have the data allocation outside of the MFT record space would be of this specific type. And the combination of all fragments that belong to this file is called a run list, and run lists basically are very simple combination of cluster offset, the cluster number, and the length of the run of the clusters. Cluster list or cluster run. So if the file is fragmented, there will be a list of multiple data runs using the same structure, basically again the first cluster plus the number of clusters and so on. And also in a typical file, and directory, we expect to find at least one file name, and it stores both the file size, the logical file length, which is actually visible to the user, and the amount of how much disk space is allocated to the number of clusters. Actually, sometimes two file name attributes may exist in 8 characters, 0.3 characters name creation scheme, which dates back to days of MS-DOS. And when this is turned on, there will be two file name attributes, one containing the long file name and one that contains the short version 8.3 formula of the name. I think we will see examples of this type of structure in our examination of this file Cobra and other objects on this file system. And file name attribute also has a combination of timestamps for created, modified, and accessed. However, compared to standard information, which really is where this information is coming from in most cases, the timestamps and file name attribute are updated only when the file name changes, and that includes the time when the file is created. So only when the file is renamed, these timestamps will be updated. Otherwise, instead of looking at the timestamps inside file name attribute, the correct place in majority of situations, you must look at the timestamps stored in standard information MFT attribute.